Hey guys, I'm going to give you some notes here on how to graph the secant and cosecant, and this should help us a little bit tomorrow to get through the notes pretty fast so you can get to practice. But graphing cosecant and secant are pretty easy. You're really going to do it based off of graphing the sine and the cosine. So we've been working on graphing sine and cosine, so you should be okay in doing this. But just to give you some information here at the top, secant and cosecant, we've already talked about that those were reciprocals for cosine and sine. So if you have the secant, the reciprocal of that would be 1 over cosine, because if we just were to flip the cosine. And out here it says if the cosine equals 0, then the secant is undefined. And that should make sense, because if the 0 is in the denominator here, then this would be an undefined function. So this is what we're kind of working off of here. And since 0 can show up in the bottom here, we are going to have some areas that are undefined on our graph, and we're going to call those vertical asymptotes. Now, if you'll remember back in Unit 1 when we did vertical asymptotes with our rational functions, that's just those asymptotes that we put on the graph that our graph does not cross. So let's take a look at a few things here. Graphing secant and cosecant, what you're going to do, depending on which one you have, you're going to graph either the sine or the cosine. So if it's a cosecant problem, you're going to graph sine. If it's a cosine problem, you're going to graph the secant. And then the next thing you need to do is locate the vertical asymptotes. Now, the way that you locate the vertical asymptotes for these is once you graph the sine or the cosine, the vertical asymptotes for the cosecant and the secant will be on the sinusoidal axis. Okay, and if you'll remember, for a sine graph, the sinusoidal is at points 1, 3, and 5, and for cosine, it's at points 2 and 4. So I want to just give you what a picture of cosecant and secant graphs look like, and then I'll do an example for you here. But if you'll notice right here, we're graphing the cosecant, which is just the basic cosecant graph. And if you see here what I have in pencil on the dotted line, that is the sine of x. So what I have written in pencil there is y equals the sine of x. That's what I've graphed. Okay? Now, for a sine curve, if you'll remember, the first, the third, and the fifth point are all on the sinusoidal. And the sinusoidal for this one is the x-axis. It's right here at 0. So what happens for a cosecant graph, since those are my points on the sinusoidal, those actually turn out to be asymptotes for my cosecant curve. Now, here's what a cosecant curve is going to look like. Basically, you take this part and we're going to flip it, because cosecant is the reciprocal of sine, so we're going to flip this here. So it kind of makes sense, the whole flipping thing. We're just going to flip it and have this rotate upward and go right along our asymptotes. And then we come down here, and we had a minimum point right here that we're going to use as our reference point to flip that one downward. Now, what I have in blue there is technically the cosecant graph. This, what I had in pencil, that's really not part of the graph, but I graphed that in order to draw the cosecant. The same thing kind of happens over here with the secant curve. Notice that I've graphed a cosine curve. Y equals the cosine of x. That's this curve right here. The sinusoidal axis is still right in the middle, but this time the second and the fourth point hit right in the middle there, so that's why I put the vertical asymptotes there. And this is what a secant graph would look like. Now, here we only have sort of half of our curve, because remember, we're only graphing a snapshot. If you'll remember, this curve really does keep going in this direction here, but we're only going to graph this half. So if we were to flip this part, it's going downward here, so we're going to flip it and make it go upward here. We're only going to graph that part. Technically, it does do like this, but we're just not graphing that side of it. Here in the middle, we're going to flip this one downward, so we have our full parabola shape there. And then over here, this one's going downward. We're going to take and flip it upward. Now here again, technically this does like this, but we're not graphing that part of it. Okay, so that is what a secant graph will look like. So this is what your cosecant graphs look like. This is what a secant graph looks like. So let's just take a look at an example here, and I'm going to go through it with you, and then I'll do another example in class with you tomorrow. Okay, but now you got the basic idea. All right, so down here on the bottom of my sheet, I've got an example. I've already did everything for this, just so we can go ahead and get to graphing the secant. But it is -3 secant of 2x minus 1. Okay, now since it's a secant problem, what I'm going to graph is I'm going to graph the cosine. And once I graph the cosine and get my sketch of it, I'm going to put my vertical asymptotes in there, and then I'm going to draw my parabola shapes. And basically we're just drawing a sketch. We're not getting, a perfectly accurate graph of this. It's just a sketch of it. So, amplitude is 3, period is 360 divided by b, and b is 2 here, so that's 180. My vertical shift is -1, which is also my sinusoidal axis, which is going to be important here in just a minute. The horizontal shift is 0, which means my start is 0. My end, take my start plus my period to get the end of 180. And then for the increments, we take our period, which is 180, and we divide it by 4, and we end up with 45. And so my T-chart looks like this: 0, 45, 90, 135, 180. And since it is a cosine that I'm graphing right now, remember the second and the fourth are on my sinusoidal. And then it is a negative out in front here. We are doing a negative, so that means that these are now my minimums. My first and my last are minimums, and my middle point is a maximum. Okay, so let me just go ahead and graph the cosine here. I'm just going to make my graph go by 45s. So we got 0, 45, 90, 135, and 180. Okay, I probably could have spaced that out a little more, but that's okay. My sinusoidal was right here at -1. So that's the middle of my graph here. And if I was plotting these points, I would have 0, -4, 45, -1, 90, +2, 135, -1, and 180, -4. So this is what the cosine curve looks like for this problem. That would be graphing negative cosine. But we really want to graph is the secant. So what we do is this. I'm going to find the points that are on my sinusoidal. So 45 and 135 are the points that are on my sinusoidal. So that's the second and the fourth. What happens is those are actually going to be vertical asymptotes for my secant graph. So what I'm going to do is at 45 and at 135, I'm going to put vertical asymptotes in there. Okay? And now from there I'm going to draw the sketch of my secant graph. Okay? Now remember, secant, you don't get the full U-shaped except in the middle part. So over here on this side, this part's going upward right here. Remember, if I kept drawing the curve, it would look something like that. So that means that this one, I'm going to go downward this direction. And again, if I kept drawing the curve, it would look like that over there. You don't have to draw that piece, but you can if you want. So I'm going downward here. And then in the middle, we're going to flip this. And we're going upward, just like that. And then over here on this side, we're coming back downward again. It always goes towards the vertical asymptote. And again, if this one kept going, if I drew my graph and kept going, it would look like that. So, this technically would look like this as well. And that's how you graph a secant. Now, tomorrow in class, I'll do a cosecant problem, and I'll show you how to we'll do it with radians just to practice that, but that's the basic idea right there. See you guys in class tomorrow.